Hi, 8th grade. Welcome to Topic 1, Lesson 9, Understand Scientific Notation. By the end of the lesson, I want you to be able to say, I can use scientific notation to write very large or very small quantities. If you remember, that was also that's very close to the objective from last lesson. Sullivan discussed it. Scientists often write very large or very small numbers using exponents. How might a scientist write down the numbers shown using exponents? Well, we could do what we did last time and estimate using powers of 10. Remember, we had a number times 10 to a a number times 10 to a power. So remember, we look at the far left number is 2, but looking to the right of that is a 7. So should I go up or should I stay the same? Go up, and now we don't count the zeros. We count the place values, 1, 2, 3, 4, 5. Remember, you want to go after the number. And since it is a decimal, a very small number, should my exponent be positive or negative? Negative. What does the exponent in 10 to the 15th tell you about the value of the number? Well, it's got a positive exponent. So is it a really big number or a really small number? It tells us that it is a big number. On the next page, example 1. Write large numbers in scientific notation. Louisa is researching the appropriate distance between Earth and the Sun. Her father told her that the distance is 9.296 times 10 to the 7. In astronomy books, she found the following: 92,960,000 miles. Louisa's father used scientific notation to express the approximate distance because the distance is so great. Numbers in scientific notation have 2 factors. So there are 2 things you always have to have. The first factor, the first thing, is always a number greater than or equal to 1 and less than 10. So between 1 and 10. And the second factor is always a power of 10, meaning it's always multiplied by 10 raised to a power. Write the number in standard form in scientific notation. So we're going to take this number and put it in scientific notation. So in order for the number to be between 1 and 10, we put the decimal after the 9. So it would be 9.296. And we want to move our decimal from here. Count how many spaces. 1, 2, 3, 4, 5, 6, 7. The 2 numbers represent the same distance, so they were both correct. The height of Angel Falls, the tallest waterfall in the world, is 3,212 feet. How would you write this number in scientific notation? Well, I need to find a number that's between 1 and 10. So if I put the decimal point right where the comma is, 3.212 is between 1 and 10. So now I need to figure out how many spaces I would move to get the decimal point from the original spot to where we want to change it. And you move 3 times. So it's times 10 to the 3rd power. Why do very large numbers have positive exponents when written in scientific notation? Because you move the decimal to the right. Next page, example number 2. Write small numbers in scientific notation. What is the width of a red blood cell written in scientific notation? So again, you still need to have a number between 1 and 10, and then a power of 10. I'm going to rewrite this number so it's a little bigger. Oops. 0.703. Well, if I want my number to be between 1 and 10, I need to put my decimal there at 7.03. So I'm going to count 1, 2, 3, 4, 5, 6. So our answer is going to be 7.03 times 10 to the negative 6. Remember, if it's a small number, it's a negative exponent. Try it. A common mechanical pencil lead measures about 0.005 meters in diameter. How can you express this measurement using scientific notation? Pause the video and try that one on your own. Okay, you should have gotten 5 times 10 to the negative 3, because our number is 0.005. To make it a number between 1 and 10, I want it to be 5, so I'll put my decimal point there and count 1, 2, 3. Since it's a decimal, it is negative. Convert scientific notation to standard form. Kelly used a calculator to multiply large numbers. How can she write the number on her calculator screen in standard form? Okay, to save room, the E on your calculator is the same thing as saying times 10, and then the next number that comes is your power. So here, 3.5e 15 means 3.5 times 10 to the 15th. So now we know it's a positive number. It's a positive exponent. So we know we're going to make this a really big number. So we're going to move it to the right. So 3.5, I need to move 15 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What do you think we're going to fill in the empty humps with? Zeros. So we're just going the opposite way. Okay, now 8 times 10 to the 9th. If I've got a negative exponent, 10 to the negative 9th, I'm going to start with 8, but I know my number is going to be really small. It's going to be a decimal, so I have to move to the left. So 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. My decimal point is here. Fill in the empties with zeros. I want you to try A and B on your own, and then we'll go over it. So 9.225 times 10 to the 18th. So I'm going to move 18 spaces to the right because it's positive. Fill in the empties with zeros. All right, now 6.3. I'm going to write it over here. 6.3 times 10 to the negative 8. So negative, I want to move left to make it a decimal. 1, 2, 3, 4, 5, 6, 7, 8. Decimal point should be there. Fill in the empties with zeros. Okay? So, scientific notation is a way to write very large numbers or very small numbers. Scientists use scientific notation as a more efficient and convenient way of writing such numbers. A number in scientific notation is the product of two factors. The first factor must be greater than or equal to 1 and less than 10. The second factor is a power of 10. So, here are two more examples. To recap, first thing that's going to happen, the first number has to be between 1 and 10. So that's that part. You got times 10 to a power. Second thing, if your power is positive, it is a big number. If your power is negative, it is a small number. All right, guys, I hope you have a super great day.